Secure design and secure coding guidelines exist to reduce recurring vulnerabilities systematically, rather than relying on individual vigilance or last-minute fixes. Most serious weaknesses do not arise from exotic attacks, and they come from familiar patterns repeated across systems and teams. Guidelines provide a shared baseline that turns hard-won lessons into default practice, so teams do not have to relearn the same failures with every project. When design and coding expectations are clear, security becomes a property of how work is done, not an extra step bolted on later. The real value is consistency, because consistency is what prevents small mistakes from scaling into systemic risk.
Secure design guidelines focus first on architecture, because design decisions determine what kinds of failures are even possible. Trust boundaries define where assumptions change, such as between users and services or between internal components and external dependencies. Least privilege at the design level ensures that components have only the access they require, limiting blast radius when something fails. Safe default behavior means that if something is misconfigured or partially implemented, the system fails closed rather than open. These principles shape the system before any code is written, which is why design guidance is often more powerful than coding rules alone. Threat modeling concepts support secure design by helping teams think deliberately about misuse cases and attacker behavior early. Instead of asking only how the system should work, threat modeling asks how it could be abused if assumptions fail. This includes considering who might attack, what assets they would target, and what paths they might use. The exercise highlights where controls are required, where logging is essential, and where design changes could eliminate entire classes of risk. Threat modeling is not about predicting every attack, and it is about identifying the most plausible and impactful failure modes. When performed early, it saves time by preventing fragile designs from moving forward. Secure coding guidelines translate design intent into safe implementation patterns that developers can apply consistently. These guidelines define how input should be validated, how output should be encoded, and how data should be handled as it moves through the system. Clear rules reduce ambiguity, which is important because ambiguity leads to inconsistent behavior across code bases. Coding guidance also helps new developers align quickly with security expectations rather than relying on tribal knowledge. When teams share a common set of safe patterns, reviews become faster and defects become easier to spot. Authentication and authorization deserve explicit attention because confusion between the two is a common source of vulnerability. Authentication establishes who an entity is, while authorization determines what that entity is allowed to do, and both must be enforced consistently. Secure coding guidelines should require that authorization checks are explicit and centralized rather than scattered and implicit. Every endpoint that performs a sensitive action must verify permissions, even if upstream components already performed checks. Consistency matters because attackers look for the one path where enforcement was assumed rather than implemented. Clear guidance prevents accidental exposure through overlooked endpoints. Secrets management is another area where secure coding guidance prevents long-term risk. Credentials, keys, and tokens should never be embedded directly in source code or configuration files that are widely distributed. Secure guidelines require the use of dedicated secret storage mechanisms that enforce access control and support rotation. This reduces the likelihood that secrets are leaked through repositories, logs, or backups. It also allows compromised secrets to be replaced without code changes. When secret handling is standardized, teams avoid one of the most persistent and damaging categories of security failure. Error handling guidance helps balance operational troubleshooting with protection of sensitive information. Detailed error messages are useful during development, but they can expose internal logic, stack traces, or data structures when surfaced to users. Secure coding standards require that external error responses remain generic, while internal logs capture sufficient detail for diagnosis. This separation protects the system without blinding operators. Consistent error handling also reduces information leakage that attackers use to refine exploits. When handled properly, errors become useful signals rather than unintended disclosures.
Logging guidelines ensure that security-relevant events are captured in a way that supports detection and investigation. This includes authentication attempts, authorization failures, administrative actions, and changes to sensitive data. At the same time, logs must avoid exposing private or sensitive content unnecessarily because logs are often widely accessible. Secure logging guidance defines what to log, how to structure entries, and how to protect log integrity. Good logging practices allow teams to understand what happened without creating a new data protection problem. Logging becomes a control, not just a debugging aid. Dependencies introduce risk even when application code is well written, which is why guidelines must address third-party libraries and frameworks. Secure dependency guidance defines which sources are approved, how versions are selected, and how updates are managed. This prevents teams from pulling in unvetted components that may carry known vulnerabilities or weak maintenance practices. It also supports faster response when issues are disclosed because ownership and update paths are clear. Managing dependencies deliberately reduces exposure that is otherwise invisible until exploited.
Secure configuration guidance addresses how applications and services are deployed and operated because unsafe defaults are a frequent cause of compromise. Debug modes, test interfaces, and administrative endpoints should be disabled or restricted in production environments. Configuration guidelines ensure that security settings remain enforced even as systems scale or are redeployed. This is particularly important in automated environments where misconfigurations can propagate rapidly. Secure configuration turns deployment into an extension of secure coding rather than a separate risk domain. Code review standards provide a structured way to enforce guidelines consistently across teams. Reviews should define what security aspects must be checked, such as input validation, access control enforcement, and secret handling. Clear standards prevent reviews from becoming subjective or superficial. Documentation of review outcomes also supports accountability and learning because patterns of recurring issues can be identified and addressed systematically. When review expectations are explicit, security becomes part of normal quality rather than an optional concern. Secure defaults are a powerful design and coding principle because they protect systems even when users or operators make mistakes. When features start disabled, permissions start minimal, and protections start enabled, unsafe deployments become harder to achieve accidentally. Secure defaults also reduce reliance on documentation being read perfectly, which is rarely realistic. This principle acknowledges that misconfiguration will occur and designs systems to be resilient to it. Over time, secure defaults prevent entire classes of incidents without requiring ongoing effort. Coding standards support consistency across teams, languages, and projects, which reduces accidental, unsafe shortcuts. When developers move between systems, familiar standards reduce cognitive load and error. Standards also make automated analysis and review more effective because patterns are predictable. Consistency does not mean rigidity, and it means shared expectations about what safe code looks like. This shared understanding scales security beyond individual expertise. Secure design and secure coding guidelines ultimately create repeatable safety expectations across architecture and implementation. They reduce reliance on individual judgment by embedding proven practices into normal workflows. When design principles guide structure and coding standards guide execution, vulnerabilities become exceptions rather than norms. Guidelines also support faster delivery because teams spend less time debating basic security decisions. In the long run, clear guidance turns security from a reactive activity into a stable property of how software is built. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.